So here's my sine function. In order to take the inverse of the sine function, any function for that matter, to be a function, it has to pass what test? The vertical line test. In order for its inverse to be a function, horizontal line test. So looking at sine right here, I'm looking to take the inverse of it. Does it pass the horizontal line test? Fails it. How many times? Infinitely many, right? So what I have to do when I'm dealing with inverse trig functions, because think about all of your trig functions that we graphed. Do any of them pass the horizontal line test? No. None of them do. Yeah. So none of them do. So what I have to do on every single one of these is put a domain restriction on it. A domain restriction. So what I'm going to do is I'm going to start erasing this, and you just let me know when it passes the horizontal line test, all right? Just hang on, I'll keep going. No. There. So this little section of my sine graph is what I am going to be able to take the inverse of. Question is, I know I went from 1 to -1 this way. I'm going to switch all my x's and y's just as I did in pre-calc A, but on my x-axis, what value did I cut it off at? Half a pi, absolutely. Pi over 2 and negative pi over 2. All right? So normally, like on the quiz up there, it says sine of 180 degrees. You gave me an answer between 0 and 1. You gave me one of these blue answers up and down. Now, you're going to have to tell me the angle. However, your angle is going to have to be between negative pi over 2 and pi over 2. I'll explain more later, maybe. We're good right now. Just know negative pi over 2 and pi over 2. Right? Or ask Maddie for help. Let's try cosine. Cosine starts on the hill, okay. And so I'm good on that, right? It passes the horizontal line test? No, it does not. All right. Sorry. Am I good? Right there. Whew. So that was rough. So I see in the y direction here, I went 1 to -1. I scaled it, of course, so you could actually see it on here. So the question is, how far did I go in the x direction on this? I'll give you the left side, 0 to what? Pi over 2? Pi? 6? How long would it take if I came all the way back up to the hill again? 2 pi, right? So I went halfway, so 0 to pi. So here in a minute, I'm gonna give you a cosine ratio, and you're gonna have to tell me what the inverse is. And so you have to make sure you tell me an angle is between 0 and pi, because that's what the domain restriction went down to. We're getting there. We're getting there. Eventually, we'll get to that. That seems. We're gonna pull that out in just. We'll pull that out in just a minute. Tangent inverse. So yeah. So yeah, I agree. It's just gonna be one snake on a plane. Question is, what does that snake go from? Disagree. Pi over 6. No. Pi over 4. Nope. Think about it. I'm just wanting where these vertical isotopes are. Where are the vertical isotopes? It's just tangent x. Where's tangent undefined? Okay, y over x is 1 over 0. Where does that happen at on your circle? pi over 2, right? Pi over 2 and negative pi over 2. Remember, the period for tangent is only pi units because everything that happens in the first quadrant happens again in the third quadrant. So we're just going to go negative pi over 2 to pi over 2. It's the same as sine, absolutely. Correct. Correct. But we only have to go to here right now. Okay? I'll save that fun for later. So what I'm going to do now is I'm going to take all of these graphs and I'm going to flip all of their x's and y's. Now, the book has you graphing these. I've never seen it on there, but if I flip all the x's and y's, this is what it looks like now. I am not worried about graphing these, okay, at all. But just to let you know, that's what the inverse looks like with that domain restriction. The big things that you need to know for this is the range. These are your possible values right here. And like you said, tangent and sine are very similar. They're negative pi over 2 to pi over 2, and then negative pi over 2 to pi over 2. The only difference is you can include these because there's no vertical isomers up there. Cosine is the weird one that you have to go 0 to pi on. All right, so you don't have to graph these. All right, there is such thing as graphing these and doing transformations with them and everything. We don't do that in here. All right. Nope, it's not. It's a pre-cal thing. I don't. What does this look like? It looks like, no. Cube root. Cube root of x. Yes. I'm not going to try to throw you off. I'm not going to ask tangent inverse of something that's undefined. Everything I give you will be defined for now. Cotangent, that's a good question. We might come across that in the homework, but again, you would just do one snake, and it would actually be 0 to pi. I was going to cover that, but we're just going to do this right now. All right, so evaluate the following. So here's what we're going to do. So as you can see, the answer that you're used to giving is going to be on the right side, on the left side, my right. And you have to give the angle now. Hey, it's the same thing that we did back when we did SOHCAHTOA. Remember we hit the sine inverse button? I said only use sine inverse, cosine inverse when you're looking for an angle. I am looking for an angle on this. All right, so I take sine inverse of what angle? It gives me 1/2. Pi over 6. 30 degrees. 30 degrees, pi over 6, whichever one you want to give me. I will accept both of those. You will see me write it in radians because I want you thinking more that way. Easy enough? That's it. How did we get that? How did we get that? Sine, cosine, tangent table. There's a 1/2 right there. That's the inverse notation. Yeah, let's do that one. Cosine inverse of 1/2. Is it? Okay. Negative pi over 3? Pi over 3? 5 pi over 6? Is it positive or negative? It's positive. It's positive, so therefore anything I take an inverse of and it's positive, I'm going to get from what quadrant? The first, every time. Every time. So what will be the inverse of this? Pi over 3 out of the first quadrant. I don't know what I said. Is it positive? No. Oh, Jaron had a good question. I like it. He said, why don't we get 2 answers for these? Because isn't there another spot on my unit circle I can take cosine of pi over, or I can take cosine and get 1/2. What is it? 5 pi over 3, right? Why am I not including 5 pi over 3? The domain restrictions. Cosine had to be what? 0 to pi. Get out your unit circles. Everybody get out your unit circles from way back in the day. Remember when that was our biggest headache?
No, I don't even know where those are.
Look off of neighbors. All right, because I'm gonna amp it up a little bit. No. I didn't do that yet. Cosine inverse of negative square root of 2 over 2. So, keep this in mind. First of all, it's cosine. So I want you to do this real quick. Everybody put your finger on 0 on your unit circle, 0 radians. And I want you to go around the outside of your unit circle all the way around to pi. Everybody with me? Everybody do this motion right here. This is really good for the video when they can't see me doing this. But I am making the St. Louis arch. Except for it's not the eccentricity of it. Oh man, we did that this morning. That was weird. Okay, any of these values I'm pointing at are fair game for cosine. Okay, so my job is all those values I just pointed at, they're between 0 and pi, which one gives me negative square root of 2 over 2 for cosine? 3 pi over 4, and that's my answer. We have all the values memorized because we've had 4 pop quizzes. Put it on your note card. We're going to do more of these. No. I mean, that just means I'm going to go to, that means I'm going to go to where cosine is negative. What quadrant it's in? Quadrant 2. It's negative. And I'm going to go grab it out of it. Now, and they don't always use cosine inverse. Sometimes they write arc sine. That means sine inverse. It's the same thing. It's just excuse me. Okay, now sine. Where does sine start at? What was its first number in its domain? Negative pi over 2. Everybody put your finger on negative pi over 2. Same as 3 pi over 2, right? All right, let's do this then. Let's put our finger on 0. Sorry, 0. Go down to negative pi over 2. All right, come back to 0. Negative pi over 2. So if I'm getting anything that's negative from sine, I'm going to get it from this 4th quadrant down here, right? All right, now we're at negative pi over 2. Everybody with me? Go all the way around. Go to 0. Go to pi over 2. All right, so anything that's positive is going to come out of that first quadrant on my unit circle. Yes? Okay. So arc sine of negative 1. It's negative, so what quadrant am I going to go down to? 4th quadrant. So go down and look at that 4th quadrant. Look for where sine is negative 1. 3 pi over 2. I disagree. Negative pi over 2, right? I have to, I know, but just now hitting the
not previously signed up for the test, you will not be allowed to take it today. Only students who signed up and have occupied you may take the test. Stay November. If you order some chart tables, those charts will be available in the office after school.
I've got this. Negative pi over 2. Because remember, you told me on sine that I needed to cut it off right here to here. Negative pi over 2 to pi over 2. 3 pi over 2 is over here. You had me erase that part of it. Does that make sense? So I have to go negative pi over 2 to pi over 2. All right, let's do a couple more. Okay, hold on. You and your pod buddies, you guys worry about tangent inverse of 1. I'm going to answer this question. Yeah, I mean, let's just say it has to cover 0. No. Some math genius way back then says it has to be here. Just remember it covers 0. Tangent inverse of 1. First of all, my answer has to be between negative pi over 2 and pi over 2, right? Same as sine. So that same motion we did with sine. So someone said 3 pi over 2. That's out here. That's a no-go. Pi over 4. I agree. Pi over 4. So I think the sine, cosine, tangent table is going to help me out way more than this. Where's tangent equal to 1 at? Pi over 4. And it could be the teacher. I don't know. I do not teach this well at all. Because on cosine, you had me erase everything except for this. Everything between 0 and pi. From the table. So cosine of this one. So square root of 2 over 2 is right here. And then I'm just going to go grab it out of the stripper quadrant where it's negative. Because in the cash quadrant, it's still positive. Let's do one more. Tangent inverse. I'll do 2 more. Tangent inverse of 0. I'm giving you the ratio. You're giving me the angle. 0? Not 2 pi. Because remember, for tangent, I can only go between negative pi over 2 and pi over 2. 2 pi is way out here. 0. Not for inverses. Because I can't go out that far. I know I said one more, but that's a nice tangent value, right? Are you ready for a DHS easy button, anybody? All right. Figure it out then. All right, tangent of what angle gives me square root of 3 over 3? Pi over 6. If it is sine or tangent, watch this. If it's one of my odd functions, just pull that negative every time. Every time. If it's one of the odd functions, it'll work.
Same thing as 11 pi over 6. I got that.
It's not 11 pi over 6 though. 11 pi over 6 would be way out here. I have to stay right here. Negative pi over 6. It's the same value, and we'll eventually get to that. Even or odd, it's symmetric about the origin. Don't worry about it. Don't worry about it.
Well, you just told us that was the DHS easy button, and then you're like, don't worry.
All right, sine inverse of 3/4, negative 3/4.
Sine or sine inverse?
Yes, sine inverse of negative 3/4. Put it in a calculator. Yeah, it's not one of my nice. It's not one of my nice things. All right, not one of my nice values. So let's just type it in a calculator. Give me 4 decimal places. Give me radians. Give me radians.
Negative 0.8480. No. 0.8481.
8481. Anybody verify that?
Okay, what did you say?
Negative 0.8481.
That's literally what I said 14 times.
All right. So if it's not something nice that we can type into the calculator, or if it's not something nice that's off my unit circle, we go to the calculator. Okay? Good. Yeah, if you had it in degrees, it's just going to spit out this radian measures. If you put that down, just make sure you put a degree symbol on there. Otherwise, I assume that it's going to be radians. Yeah. All right, let's go with this. I don't know, do you want to do B or C? B? We did this back in the very beginning. I don't want to worry about Pythagorean thing. I get some nasty square root maybe. But look at angle B right there. So which trig function should I use? Why sine? I know, opposite and hypotenuse. Okay. So sine of B should be the opposite side, 24 over the hypotenuse. Alright. And so whenever sine switches sides and comes over, same thing that happened a couple months ago, I'm just going to get sine inverse of this fraction. And then that's not a nice ratio, is it? What's that, 4/5? 0.9273? And that would be the measure of this angle in radians. Can I put that on the quiz? Which might not, I don't know when the quiz on Thursday. We did it in geometry, and we did it earlier in January. This is something that was supposed to cover, according to this book up front. Let's do Mr. Bowles real quick. Is standing on top of a 50-foot building. 50-foot building. Let's draw that. Here's Mr. Bowles, right there. That's not me, that's Mr. Bowles. Is standing on top of a 50-foot building and sees his friend, Mr. Lovelady. Mr. Lovelady is 30 feet away from the base of the building. Here I am. I'm green. I'm the Incredible Hulk down here. I don't have a neck suddenly. 30 feet away from the base of the building. So this is 30. That's 50. Oh, we almost got a triangle. What is the angle of depression? Your eyes. Oh, right. It's 5.5 feet. Well, my 5.5 feet tall. So we got to add what, a 5? We got to add a 5.5 to Mr. Bowles right here, and he just sees me down here like an ant. So he sees my feet. We'll say he sees my feet. All right. Just checking out my shoes. All right. Yeah. Ah, I can't wear the red ones anymore. You guys make fun of me. So question is, which angle do I want? This one? You guys agree? Disagree. Angle of elevation, angle of depression has to be made with a horizontal right here. I'm looking for that angle. Alternate interior angles, this is going to be my angle of depression. Make it with the horizontal. You want to use tangent? All right, tangent of that theta is equal to what? Oh, 50 over 30 in this case. Should add the 5.5. 55.5 over 30. Which would just be, that's where he's looking from. Nope, he saw my shoes. I need to put that in here. I'm going to. All right, so tangent inverse of this. Show your neighbor. Cahooting tomorrow will not take the whole time. So you'll be able to work on some of this homework. 55.5. I don't know where the 3 came from. It's going to be an awesome recording. Sorry, Shay. Oh. Hi.
Annie says hi.
She hears you. It's loud. What did we get? 1.075. 0.0752 in radians. All right. It's not going to take very long if you want to hash some of this out. Hash some of it out if you're needing some bonus. You win Kahoot tomorrow, you get bonus. All right. We'll work on some homework tomorrow. Might get started in on the rest of this. Have a good day.